Venus is one of the most mysterious and intriguing planets in our solar system. It is known as Earth's sister, as the two planets share nearly identical size, mass, and density. However, while Venus and Earth may seem similar at first glance, their internal worlds and atmospheres are vastly different. Venus is a world of extremes, a place where extreme conditions are the norm, and science reveals its secrets with each new observation. The surface of Venus is hidden beneath a dense cloud cover that prevents direct observation with ordinary telescopes. These clouds are primarily composed of sulfuric acid, making Venus' atmosphere one of the most toxic in the solar system. Even more astonishing are its climatic conditions. The surface temperature reaches 475 degrees, which is hotter than Mercury, despite Venus being farther from the Sun. This greenhouse effect is caused by the thick atmosphere, which consists of 96% carbon dioxide, trapping heat and preventing it from escaping into space. Studying Venus has long been a challenging task for humanity. The first attempts to explore the planet, made in the 1960s, led to significant discoveries. The Soviet probes of the Venera series were the first to reach the surface and transmit photographs. These missions revealed that the planet's surface is covered with vast volcanic plains, numerous craters, and evidence of active volcanism. The presence of many volcanoes, including colossal shield volcanoes, indicates that the planet has undergone powerful geological processes in its past. Interestingly, Venus lacks tectonic plates like those on Earth. Instead, its crust appears to periodically heat up, to the point of breaking and reforming. This means that Venus does not have ongoing tectonic activity like our planet, and its surface may undergo catastrophic changes when accumulated heat is released. These processes make Venus a unique laboratory for studying geological phenomena that may occur on other planets and even exoplanets. The atmosphere of Venus is another fascinating aspect of its story. Winds in the upper layers of the atmosphere reach speeds of up to 360 km/h, creating incredible vortices and hurricanes that continuously circulate around the planet. These winds are much faster than the planet itself rotates on its axis. A single day on Venus lasts 243 Earth days, making it longer than a year on Venus, which is about 225 Earth days. This phenomenon, slow rotation and rapid winds, continues to puzzle scientists and raises many questions about the nature of the planet's atmosphere. One of the most exciting topics related to Venus is the possibility of life in its atmosphere. Despite the extreme conditions on the surface, scientists speculate that at an altitude of about 50 to 60 kilometers above the surface, the temperature and pressure may be suitable for microbial life. In 2020, the detection of phosphine, a gas associated with biological processes on Earth, sparked intense debate and hope for the possibility of life in Venus's clouds. Although further studies have yet to provide definitive answers, the mere idea of searching for life on such a different planet inspires scientists to continue their investigations. Venus remains the focus of numerous scientific missions. In the coming years, NASA and the European Space Agency plan new missions to this remarkable planet to answer questions about its history, geology, and potential habitability. Venus is a reminder of how diverse and astonishing our cosmic home is. It opens a window into the past, helping us understand how similar planets can evolve along completely different paths. And perhaps in studying Venus, we may find the key to understanding not only its nature, but also the future of our own planet. One of the upcoming missions to Venus is NASA's Da Vinci Plus Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging mission, which aims to study the composition of Venus's atmosphere and gather high-resolution images of its surface. Da Vinci Plus will descend through the thick cloud layers, providing unprecedented insights into the planet's atmospheric chemistry and its evolution. By studying noble gases and other key atmospheric components, scientists hope to learn more about Venus's past, including how it might have once had oceans and a more temperate climate before experiencing a runaway greenhouse effect. Another mission, NASA's Veritas Venus Emissivity, Radioscience INSAR, Topography, and Spectroscopy, will focus on mapping the surface of Venus in detail. Using radar imaging, Veritas will create high-resolution topographic maps to help understand the planet's geologic history and the processes that have shaped its surface. The mission will also investigate whether active volcanism still occurs on Venus today, shedding light on the planet's thermal evolution and the dynamics of its interior. The European Space Agency ESA is also contributing to Venus exploration with its mission called Envision. Envision will study the surface and atmosphere of Venus, focusing on understanding the geological activity and how the surface interacts with the atmosphere. By combining radar and infrared observations, Envision will provide a comprehensive view of Venus's current state, furthering our understanding of why Venus and Earth, which started with similar conditions, ended up so dramatically different. These upcoming missions promise to revolutionize our knowledge of Venus, potentially uncovering clues about the planet's habitability in its distant past and offering a deeper understanding of how terrestrial planets evolve in general. By comparing Venus, Earth, and Mars, scientists can piece together a broader picture of planetary development and the factors that make a world suitable for life. Venus also serves as an important analogue for exoplanets, planets orbiting other stars. Many of the exoplanets discovered so far are similar in size and composition to Venus, and studying our sister planet can help scientists interpret the observations of these distant worlds. The study of Venus, with its thick atmosphere and extreme greenhouse effect, may provide insights into the conditions of similar exoplanets and help us determine whether they could potentially harbor life. Ultimately, Venus is a reminder of both the beauty and the harshness of our universe. It teaches us that even planets that seem Earth-like can develop in profoundly different ways, and it underscores the delicate balance that allows life to thrive on our own planet. As we continue to explore Venus, we gain not only knowledge about a neighboring world, but also a greater appreciation for the unique conditions that sustain life on Earth. Venus's harsh environment, with its intense heat and crushing atmospheric pressure, serves as a cautionary tale for our own planet. The study of Venus's runaway greenhouse effect provides crucial insights into the impact of atmospheric changes and climate instability. Understanding the processes that transformed Venus into a hostile world can help us better grasp the potential consequences of unchecked greenhouse gas emissions on Earth. By learning from Venus's fate, we can take steps to protect our own planet from a similar outcome. In addition to its value in climate studies, Venus's geological history holds clues to the evolution of rocky planets. The study of volcanic features and surface composition could reveal much about the processes that shaped not only Venus, but also Earth and other terrestrial planets. For instance, understanding how Venus's crust behaves under extreme conditions can help scientists develop models to predict geological activity on similar worlds, both within and beyond our solar system. One intriguing mystery that scientists are keen to solve is whether Venus had liquid water in the past. There is evidence suggesting that billions of years ago, Venus may have had oceans and a more temperate climate, making it potentially habitable. The question of what caused Venus to transition from a possibly Earth-like environment to the uninhabitable one we see today is critical for understanding planetary habitability. By piecing together Venus's climatic past, we may gain insights into the conditions required for a planet to maintain stable, life-supporting environments over long periods. The exploration of Venus is also important for our understanding of atmospheric dynamics. The phenomenon of superrotation, where the atmosphere rotates much faster than the planet itself, is still not fully understood. By studying the interactions between Venus's atmosphere, surface, and solar radiation, scientists hope to unlock the secrets behind this unusual atmospheric behavior. Such knowledge could also be applied to understanding atmospheric processes on other planets, including gas giants like Jupiter and Saturn. As we look to the future, Venus represents an exciting frontier for both robotic and potentially human exploration. While the extreme conditions make a manned mission to Venus's surface highly challenging, some scientists have proposed the concept of floating cities in the upper atmosphere, where conditions are less hostile. These floating habitats could serve as basis for extended study of Venus's atmosphere and surface, potentially paving the way for future exploration of similar environments on exoplanets. The mysteries of Venus continue to captivate us, reminding us of the diversity of worlds that exist within our own solar system. Each new mission brings us closer to unraveling the planet's secrets and understanding its history. The lessons we learn from Venus may not only help us better appreciate our own world, but also guide us as we venture farther into the cosmos, seeking out new planets and possibly even new forms of life. Despite the numerous challenges posed by Venus, the scientific community remains undeterred, driven by the desire to answer fundamental questions about our neighboring world. Venus is a window into the processes that can shape planets over billions of years. Its story is one of transformation, from a potentially habitable world to a hostile environment, and in that transformation lies the potential to understand our own planet's fragility. As we stand on the cusp of new discoveries, Venus invites us to explore not just its hostile landscapes and toxic clouds, but also the profound questions it raises about life, climate, and the future of our solar system. One particularly tantalizing possibility is the study of Venus as an example of what could happen to Earth under certain conditions. Its atmosphere, thick with carbon dioxide, shows what unchecked greenhouse effects can do. This makes Venus an important subject for studying the long-term consequences of climate change and helps us think more deeply about the potential outcomes of our actions on Earth. By learning how Venus became so inhospitable, we may find crucial lessons on how to preserve the delicate balance of our own planet's environment. Moreover, Venus challenges our understanding of what makes a planet habitable. While we often think of Earth-like conditions as necessary for life, Venus suggests that there may be other pathways for habitability, even in places with extreme conditions. The possibility that microbial life might exist in Venus's upper atmosphere, despite the harsh surface conditions, expands our perspective on where life might be found, both within our solar system and beyond. In the broader context of space exploration, Venus represents a critical stepping stone for humanity's ambitions. Future missions to Venus will test technologies that could eventually be used on other planets, including those orbiting distant stars. The study of Venus will not only add to our knowledge of the solar system, but also prepare us for the exploration of exoplanets with similar characteristics. As we push the boundaries of our scientific capabilities, Venus will continue to serve as a challenging yet rewarding target, promising new insights into planetary science and the conditions that shape the cosmos. Venus is a testament to the resilience and curiosity of human exploration. The lessons we learn from our sister planet could very well inform our efforts to sustain life on Earth and guide our search for life elsewhere in the universe. With each mission, we come one step closer to unlocking the secrets of Venus, and in doing so, we also learn more about ourselves and the universe we inhabit. The journey to understand Venus is far from over, and the discoveries awaiting us could forever change our perspective on what it means to be part of a cosmic community. The upcoming missions to Venus also represent a new era of international collaboration in space exploration. With NASA, ESA, and other space agencies working together, the study of Venus is becoming a collective human endeavor. This cooperative spirit is essential as we tackle the big questions about our place in the universe. By sharing data, expertise, and resources, scientists from around the world can accelerate our understanding of Venus and, by extension, other similar planets. In addition to robotic missions, there is also a growing interest in sending crewed missions to Venus, not necessarily to its surface but to its upper atmosphere. The concept of cloud cities or floating habitats in the Venusian atmosphere is an intriguing possibility. These habitats would float at altitudes where temperatures and pressures are relatively Earth-like, offering a unique environment for long-term study. Such missions could pave the way for human habitation of extreme environments, testing our ability to adapt and survive in conditions vastly different from those on Earth. The study of Venus also raises fundamental philosophical questions about the nature of life and the conditions required for its existence. If life does exist in the clouds of Venus, it would challenge our understanding of biology and the adaptability of life forms. It would suggest that life is not only tenacious but also capable of thriving in environments previously thought to be entirely hostile. This possibility keeps scientists inspired and motivates further exploration. Venus's extreme environment is also a powerful reminder of the importance of planetary stewardship. As we continue to explore our solar system, Venus serves as a stark illustration of how planetary conditions can change dramatically. The runaway greenhouse effect that transformed Venus into a scorching world is a cautionary tale for Earth. It highlights the delicate balance required to maintain a stable climate and underscores the importance of addressing climate change to ensure that our planet remains habitable for future generations. In the coming decades, as new missions reach Venus and bring back data, our understanding of this enigmatic planet will grow exponentially. Each new discovery will add pieces to the puzzle of Venus's past, its present conditions, and its potential for supporting life. And as we learn more about Venus, we also gain new insights into the other rocky planets in our solar system and beyond. With its thick clouds and searing heat, may seem like an unlikely place for hope. Yet it is precisely in the challenges it presents that we find inspiration. The quest to understand Venus pushes the boundaries of our technology, our science, and our imagination. It reminds us that exploration is not just about finding answers, but about asking better questions, challenging our assumptions, and expanding our horizons. The journey to Venus is ultimately a journey to understand our own place in the cosmos. As we peel back the layers of Venus's mysteries, we come to better understand the forces that shape all planets, including our own. We are reminded of the fragility of habitable worlds and the extraordinary set of circumstances that allow life to flourish. And perhaps through the lens of Venus, we will come to appreciate even more deeply the rare and precious nature of our own planet, the only known cradle of life in the vastness of space. Venus is a planet of contrasts and extremes. While it shares many similarities with Earth in size and composition, its harsh conditions make it one of the most inhospitable places in our solar system. Despite these challenges, Venus has captivated scientists for decades, and its study offers valuable insights into planetary evolution, atmospheric dynamics, and even the future of Earth. The thick, toxic atmosphere of Venus is dominated by carbon dioxide, creating a runaway greenhouse effect that traps heat and results in surface temperatures hotter than those on Mercury. The atmosphere is also filled with clouds of sulfuric acid, which not only obscure the surface but also reflect sunlight, contributing to the planet's brightness when observed from Earth. This extreme environment raises questions about Venus's past, whether it once harbored conditions more conducive to life and what caused its transformation into the scorching world we see today. The surface of Venus, hidden beneath its dense atmosphere, is a volcanic landscape. Soviet missions in the 20th century, particularly the Venera program, were the first to send back images from the planet's surface, revealing a world dominated by volcanic plains, mountains, and evidence of past tectonic activity. Unlike Earth, Venus does not have plate tectonics. Instead, its surface appears to undergo periodic, planet-wide resurfacing events where heat builds up beneath the crust and is released in catastrophic eruptions. These processes highlight the importance of geological activity in shaping planetary environments and offer a glimpse into the past of rocky planets, including Earth. Venus's slow rotation is another anomaly, as the planet takes longer to rotate once on its axis 243 Earth days than it does to complete an orbit around the Sun 225 Earth days. This unusual dynamic, coupled with the planet's rapid atmospheric winds, remains a mystery that scientists are eager to unravel. Understanding the atmospheric circulation of Venus could provide insights into weather patterns on other planets, including Earth-like exoplanets. One of the most tantalizing aspects of Venus exploration is the potential for life in its atmosphere. While the planet's surface is too extreme for life as we know it, the discovery of phosphine gas in the planet's upper atmosphere has led to speculation that microbial life could exist in these more temperate regions. Although the presence of phosphine has not yet been definitively linked to biological processes, the possibility of life on Venus challenges our understanding of habitability and inspires future missions to investigate further. In the coming years, missions like NASA's Da Vinci Plus and Veritas, as well as ESA's Envision, aim to shed new light on Venus's geological and atmospheric history. These missions will explore key questions about the planet's past, including whether it once had oceans and what processes led to its current state. They will also help scientists better understand the forces driving Venus's extreme climate and how similar processes might affect other planets, including Earth. Studying Venus is not only important for understanding our solar system, but also for interpreting the properties of exoplanets. Many of the rocky worlds discovered around other stars have conditions similar to those on Venus, and by studying our closest planetary neighbor, we can gain insights into the nature of these distant worlds and their potential for hosting life. Venus serves as a powerful reminder of the fragility of planetary environments. Its transformation from a possibly habitable world to a hellish one offers lessons for Earth, particularly regarding the dangers of unchecked climate change. As we continue to explore Venus, we are not only seeking to understand the past of a neighboring world, but also to protect the future of our own. In doing so, we deepen our connection to the cosmos and expand our understanding of what it means to be a part of this vast and mysterious universe. Venus stands as a testament to the diverse evolutionary powers planets can take, reminding us that similar beginnings can lead to vastly different outcomes. While Venus and Earth are often described as twins due to their comparable size and mass, the divergence in their atmospheric conditions and surface surface environment speaks volumes about the influence of minute variations in planetary development. These variations have resulted in Venus transforming into a scorching inferno, while Earth has become a cradle for life. One of the most compelling mysteries surrounding Venus is the question of whether it once had oceans or a more temperate climate. Some scientists hypothesize that Venus might have been more Earth-like in its early history, with liquid water covering much of its surface. If true, this would suggest that Venus underwent a dramatic climatic shift, possibly triggered by a runaway greenhouse effect, where the accumulation of heat-trapping gases in the atmosphere reached a tipping point. Understanding the timeline and mechanisms behind this transformation could offer vital clues for climate studies on Earth, particularly regarding the long-term impacts of atmospheric changes. The planet's atmosphere, which is roughly 90 times denser than Earth's, exerts crushing pressure on the surface, equivalent to being nearly a kilometer underwater on Earth. Combined with the high temperatures, this makes Venus an incredibly hostile environment for conventional exploration. Yet, technological advancements are steadily overcoming these challenges. New missions will employ radar imaging to penetrate the thick cloud cover and map the surface with unprecedented detail. By understanding the topography of Venus, scientists hope to learn more about its geological past, including the possibility of active volcanoes still shaping the landscape today. The potential for active volcanism on Venus has intrigued scientists for decades. While Venus is covered in extensive volcanic plains, evidence for recent or ongoing volcanic activity remains inconclusive. However, some data from the European Space Agency's Venus Express mission hinted at the possibility of fresh lava flows on the surface, suggesting that Venus might not be geologically dormant after all. Confirming this would have profound implications for our understanding of Venus's internal dynamics and the processes that sustain volcanic activity on rocky planets. Beyond its role in planetary science, Venus is becoming a key player in astrobiological research. The discovery of phosphine gas in Venus's clouds, an unexpected and controversial finding, ignited debates about the potential for microbial life in its upper atmosphere. Although the surface is too extreme for any known life forms, the upper layers of Venus's atmosphere, where temperatures and pressures are more Earth-like, could offer a niche environment where life might exist. If life were found in such an alien environment, it would revolutionize our understanding of biology and challenge the idea that life requires Earth-like conditions to survive. However, the phosphine discovery also highlights the need for caution in interpreting scientific data. Follow-up observations have provided mixed results, and alternative explanations for the presence of phosphine, such as unknown chemical processes, are still being considered. Regardless, the mere possibility of life on Venus has reinvigorated interest in the planet and underscored the importance of continuing our exploration of its complex atmosphere. Looking to the future, Venus may also play a crucial role in preparing humanity for the exploration of exoplanets. With its dense atmosphere and extreme greenhouse effect, Venus shares many characteristics with the super-Earths and hot Jupiters discovered orbiting other stars. By studying Venus in detail, scientists can develop models to predict the climates and potential habitability of these distant worlds. This knowledge will be essential as we begin to explore exoplanets more closely with next-generation space telescopes like the James Webb Space Telescope and its successors. In many ways, Venus represents both a cautionary tale and a source of hope. Its extreme climate serves as a warning about the potential consequences of unchecked atmospheric changes, while its mysterious history and potential for past habitability offer a glimpse of what Earth might have looked like in a different era. By studying Venus, we gain insights into the forces that shape planets and the delicate balance required to maintain environments conducive to life. One of the more intriguing ideas proposed by scientists is the possibility of human exploration in Venus's atmosphere. While the surface is too hostile for human missions, the concept of floating habitats in the planet's upper atmosphere, where conditions are relatively more temperate, has gained traction. These cloud cities could be platforms for extended study of Venus's atmosphere and surface, providing a way to explore the planet without facing the extreme conditions on the ground. This concept, while still in its early stages, represents a bold vision for the future of space exploration and demonstrates humanity's adaptability in the face of seemingly insurmountable challenges. As we continue to unlock the mysteries of Venus, the planet remains a symbol of both the wonders and the dangers that exist in our solar system. It challenges us to expand our understanding of planetary science and to apply the lessons we learn to safeguard our own world. Venus, with its searing heat, crushing atmosphere and enigmatic past, stands as a testament to the resilience of human curiosity and our unrelenting desire to explore the unknown. The lessons Venus offers are not just about planetary science, but about our relationship with our own planet. Studying Venus helps us understand the delicate balance of forces that keep Earth habitable, reminding us of the need to protect and preserve our environment. As we continue to explore Venus and other worlds, we gain a deeper appreciation for the rarity of life and the unique conditions that allow it to flourish. Ultimately, the study of Venus is a journey of discovery about our past, our future, and our place in the universe. Each new mission, each new observation, brings us closer to understanding the profound questions that Venus raises about planetary evolution, habitability, and the nature of life itself. The exploration of Venus is not just about unraveling the mysteries of a neighboring world. It is about deepening our connection to the cosmos and our understanding of the forces that shape all planets, including our own. Venus, with its unique set of conditions, continues to be a laboratory for understanding not only our own solar system, but also the mechanisms that might be at play in other planetary systems. The stark differences between Venus and Earth serve as a reminder of how even small changes in a planet's initial conditions or position within its star's habitable zone can lead to vastly different outcomes. This divergence provides scientists with crucial data points for comparing terrestrial planets and assessing the potential for life on exoplanets. One of the most significant scientific pursuits regarding Venus is its climate history and the dramatic changes it underwent. There is mounting evidence to suggest that, early in its history, Venus may have had surface water in the form of oceans or lakes, and possibly a more temperate climate. This makes Venus an important case study for understanding how planets that might initially appear Earth-like can evolve into hostile environments. It also presents an invaluable opportunity to study the greenhouse effect on a planetary scale. Venus's extreme greenhouse effect, driven by its thick atmosphere composed predominantly of carbon dioxide, has turned the planet into a hothouse, with surface temperatures hot enough to melt lead. This runaway greenhouse effect offers scientists a crucial opportunity to understand climate processes that could, under certain conditions, affect Earth. The study of Venus provides a cautionary glimpse into the possible future consequences of runaway climate change. As scientists on Earth seek solutions to mitigate the impact of rising greenhouse gas levels, Venus serves as a stark reminder of what could happen if such processes are left unchecked. The geology of Venus also offers exciting insights. Unlike Earth, which has a system of tectonic plates that shift and reshape its surface, Venus seems to lack this form of tectonic activity. Its surface appears to have undergone catastrophic resurfacing events in the distant past, where vast areas were flooded by lava and the planet's crust was renewed. This resurfacing, coupled with the lack of current tectonic movement, makes Venus a unique laboratory for studying planetary interiors and surface dynamics. The absence of tectonic plates raises questions about how heat is released from the planet's interior and what this could tell us about the evolution of rocky planets more broadly. Volcanism on Venus remains one of the planet's most fascinating yet poorly understood features. Many of the volcanic structures visible on the planet's surface, such as shield volcanoes, lava plains, and large calderas, indicate that Venus was once a highly geologically active world. Some evidence even suggests that volcanic activity may still be occurring on Venus today. Understanding Venus's volcanism could provide insights into the thermal evolution of rocky planets and how volcanic activity influences atmospheric composition over time. Missions like Veritas are expected to reveal more about the current state of Venus's volcanic activity by mapping the planet's surface in detail, offering a clearer picture of its geologic history and internal dynamics. One particularly intriguing aspect of Venus's atmosphere is the phenomenon of superrotation, where the atmosphere circulates the planet much faster than the planet itself rotates. While a day on Venus lasts 243 Earth days, the upper atmosphere moves at a blistering pace, completing a full rotation in just 4 days. This extreme difference between surface rotation and atmospheric circulation remains one of Venus's most puzzling characteristics, and it offers a valuable opportunity to study atmospheric dynamics in a high-energy environment. Understanding the mechanisms driving superrotation could help scientists refine their models of atmospheric behavior on other planets and even gas giants. The atmospheric layers of Venus are also home to one of the most exciting and controversial debates in planetary science: the potential for microbial life. In 2020, the detection of phosphine, a chemical often associated with biological processes, in the clouds of Venus sparked intense discussions within the scientific community. While some researchers argue that the presence of phosphine could be a sign of microbial life surviving in the temperate regions of Venus's atmosphere, others caution that unknown chemical processes might explain the findings. The debate highlights how little we know about the chemistry of Venus's atmosphere and emphasizes the need for more in-depth exploration of the planet's cloud layers. Whether or not life exists in the clouds of Venus, the mere possibility has reignited interest in studying our neighboring planet. Beyond the scientific implications, Venus also holds a unique place in the history of space exploration. The Soviet Union's Venera missions marked the first successful landings on another planet, with Venera 9 and 10 sending back the first images from Venus's surface. These missions demonstrated the resilience and ingenuity required to explore one of the most hostile environments in the solar system. Despite the immense challenges posed by Venus's crushing atmospheric pressure and searing temperatures, the early Venera probes paved the way for future missions. As new technology becomes available, missions like Da Vinci Plus, Veritas, and Envision will build on these early efforts, offering a new generation of explorers the tools needed to unlock Venus's secrets. As space agencies around the world prepare for these missions, Venus stands as a critical frontier in our understanding of planetary science. The study of Venus not only offers insights into the workings of our own solar system, but also informs our search for life beyond it. Many of the exoplanets discovered to date share characteristics with Venus, particularly those orbiting within their star's habitable zone but exhibiting thick atmospheres and high surface temperatures. By studying Venus in detail, scientists can better understand how to interpret data from these distant worlds and assess their potential habitability. Looking even further ahead, some scientists have speculated about the possibility of human exploration of Venus. While the planet's surface remains too hostile for crewed missions, the concept of floating habitats in Venus's upper atmosphere offers a potential solution. At altitudes between 50 and 60 kilometers, temperatures and pressures are more similar to those on Earth, making this region one of the most Earth-like environments in the solar system. These floating cities, equipped with advanced life support systems, could serve as platforms for extended exploration of Venus's atmosphere and surface, allowing scientists to study the planet up close without being exposed to its extreme surface conditions. The study of Venus challenges our assumptions about planetary environments and the conditions required for habitability. While Earth and Venus may have started with similar characteristics, their evolutionary paths diverge dramatically, offering a cautionary tale about the fragility of habitable worlds. Venus's atmosphere, climate, and geology provide a wealth of information about the processes that shape planets, and its exploration could help scientists better understand the broader universe. As we continue to explore Venus, we are not only unraveling the mysteries of a neighboring world, but also gaining insights into the forces that shape planetary environments across the cosmos. Venus is a reminder of the diverse possibilities that exist for planetary evolution and the delicate balance required to sustain life. Through the study of Venus, we are not just looking outward toward the stars, but also inward, reflecting on the conditions that make Earth such a unique and precious home. The knowledge gained from Venus may ultimately help us protect and preserve our own planet, ensuring that it remains a cradle for life in a universe full of challenges and possibilities. Venus continues to captivate scientists and the public alike, serving as both a mirror and a contrast to our own planet. As we deepen our understanding of this enigmatic world, we gain insights that extend far beyond the boundaries of our solar system, shaping our broader comprehension of planetary science and the conditions required for habitability. One of the most compelling questions surrounding Venus is whether it represents a cautionary tale for Earth. The idea that Venus, once perhaps harboring oceans and a more temperate climate, could have become the scorching, toxic world we see today forces us to consider the fragility of Earth's own climate systems. The runaway greenhouse effect on Venus serves as a stark reminder of how delicate the balance is between atmospheric composition, solar radiation, and surface conditions. For Earth, understanding Venus's transformation could offer key lessons in how to manage our own planet's future in the face of human-induced climate change. Venus's past also holds important clues for astrobiology. While the possibility of life existing on the planet's surface is unlikely given its current extreme conditions, the discovery of phosphine gas in its upper atmosphere has sparked excitement about the potential for microbial life. This tantalizing discovery opens up new avenues for thinking about where life could exist. If life can survive in Venus's acidic clouds, it challenges our Earth-centered views of habitability and suggests that life could arise in conditions far more extreme than previously thought. But beyond its role in astrobiology, Venus serves as a reminder of the dynamic forces that govern planetary evolution. The planet's thick atmosphere, laced with sulfuric acid clouds, is not just a scientific curiosity but a vital laboratory for studying atmospheric dynamics and climate. Venus's super-rotating atmosphere, where winds race faster than the planet itself rotates, presents scientists with a unique opportunity to study atmospheric circulation patterns under extreme conditions. These studies could shed light not only on Venus's climate, but also on atmospheric processes on exoplanets, some of which may exhibit similar conditions. One of the key upcoming missions to Venus is NASA's Da Vinci Plus mission, which promises to unlock the mysteries of Venus's atmosphere. By descending through the dense clouds, Da Vinci Plus will provide invaluable data about the composition of the atmosphere, its chemistry, and its potential for past habitability. This mission is crucial because it will help scientists determine whether Venus ever had oceans, and if so, what triggered the catastrophic changes that led to its current state. In studying Venus's atmosphere, scientists may also be able to discern how other planets with similar characteristics could evolve and whether they might support life. Alongside Da Vinci Plus is NASA's Veritas mission, which will map Venus's surface in unprecedented detail. Using radar imaging, Veritas will reveal the topography and geological history of the planet, offering clues about its volcanic activity, tectonics, and the processes that shaped its landscape. This detailed mapping will help scientists answer lingering questions about whether Venus is still volcanically active today. If active volcanoes are discovered, it could reshape our understanding of how Venus releases heat from its interior, despite the lack of plate tectonics. Meanwhile, the European Space Agency's Envision mission will complement these efforts by focusing on the relationship between Venus's surface and its atmosphere. Envision's radar and infrared instruments will provide detailed data on Venus's geology, particularly the processes that drive its resurfacing events. By combining radar and infrared observations, Envision will help scientists piece together how Venus's atmosphere and surface interact, giving us a better understanding of how similar planets may behave. These missions are a testament to the growing international collaboration in space exploration. As NASA, ESA, and other space agencies pool their resources and expertise, the study of Venus becomes a truly global endeavor. This spirit of cooperation is critical as we tackle the most profound questions about planetary evolution and habitability, not just in our solar system, but across the universe. Venus is also becoming increasingly relevant in the study of exoplanets. Many of the exoplanets discovered so far orbit within their star's habitable zone, but like Venus, they may have thick atmospheres and extreme surface conditions. By understanding the greenhouse effect, atmospheric dynamics, and geological processes on Venus, scientists can refine their models for predicting the climates and potential habitability of these distant worlds. The lessons learned from Venus will help us better understand how terrestrial planets, regardless of their location in the galaxy, evolve over time. Human exploration of Venus, while a distant goal, remains a topic of intrigue. Floating habitats in the upper atmosphere of Venus have been proposed as a way for humans to explore the planet without facing its extreme surface conditions. These floating bases, located in the more temperate regions of Venus's atmosphere, could allow scientists to conduct long-term studies of the planet, providing a way to explore the atmosphere and even search for signs of life in the clouds. While such missions remain in the conceptual phase, they reflect the bold vision of future space exploration, where humans venture not only to the Moon and Mars, but also to the most challenging environments in the solar system. Venus's potential as a window into planetary evolution extends beyond the physical sciences and into the realm of philosophy and ethics. As we continue to explore our neighboring planet, we are confronted with questions about our own responsibility as stewards of Earth. Venus shows us what can happen when a planet's atmosphere spirals out of control, serving as both a scientific lesson and a moral one. It underscores the need for humanity to take proactive measures in addressing climate change, not only for our own sake, but as part of our growing awareness of planetary systems and the delicate balance that sustains life. The exploration of Venus will also contribute to our broader understanding of the solar system's history. By comparing Venus, Earth, and Mars, the 3 rocky planets that may have once had water, scientists can build a more complete picture of planetary evolution and the factors that determine a planet's habitability. These comparisons are crucial for understanding why Earth has remained hospitable to life, while Venus and Mars have become hostile environments. In this way, Venus becomes a critical piece of the puzzle in unraveling the history of our solar system. In the decades to come, Venus will likely continue to surprise and challenge us. Each new mission, each new discovery, brings us closer to understanding this extraordinary planet and its place in the cosmic tapestry. The knowledge gained from Venus will ripple outwards, informing our exploration of exoplanets, our understanding of climate science, and our philosophical reflections on life and habitability. Ultimately, Venus serves as a reminder that our universe is full of worlds as complex and diverse as our own. It teaches us that planetary evolution is a dynamic process, influenced by a myriad of factors, from solar radiation to atmospheric chemistry. As we continue to explore Venus, we are not only uncovering the secrets of a neighboring world, but also gaining insights into the forces that shape all planets, including our own. And perhaps, in the process, we will find a greater appreciation for the delicate balance that makes Earth so unique in the vast expanse of space. Venus, our nearest planetary neighbor, remains one of the most intriguing mysteries in our solar system. Its study not only reveals the unique characteristics of this specific planet, but also offers deep insights into the mechanisms that govern planetary evolution throughout the universe. From its staggering climate conditions to the geological puzzles and the potential for life, Venus continually challenges our understanding of what worlds beyond Earth might look like. Each new mission to Venus brings us closer to understanding not just Venus itself, but the fundamental processes that shape planets. The exploration of its atmosphere and surface helps scientists comprehend how Earth-like planets can evolve and what factors determine their ultimate fate. Comparing Venus with Earth and Mars allows us to see different scenarios for the development of planets with similar beginnings, helping us appreciate the fragility of Earth's own environment. Venus also serves as a stark warning about how quickly planetary conditions can shift under extreme circumstances, such as a runaway greenhouse effect. It reminds us of the importance of scientific inquiry and conscious efforts to protect our planet from catastrophic changes that could threaten the conditions that make Earth habitable. The scientific discoveries awaiting us on Venus will not only enhance our understanding of the solar system, but will also contribute to the study of exoplanets, distant worlds that may share similar conditions. Venus becomes a critical piece in the puzzle, linking our exploration of the nearby cosmos with the grander search for extraterrestrial life. As Venus continues to unveil its secrets, it urges us to rethink not only our place in the universe, but also our responsibility to our home planet, Earth. The study of Venus is not just the story of a neighboring planet, but a reminder of the uniqueness of our world and the importance of safeguarding its resources and climate. Venus, with its brilliant clouds and hidden mysteries, continues to inspire humanity in the pursuit of space exploration and in the quest for answers to some of the most fundamental questions about the nature of planets, life, and our place in the vast cosmos.